the entire class that I'm teaching there, and I have to have some kind of consistent approach when we do dimensional analysis. So let's say we're always going to multiply the conversion factor. Let's focus on the unit. Okay, so that's what matters in the end. Whatever you do, as long as you get the correct unit, as long as you get the correct answer, I'm okay with it. So whatever works, and that's my approach. Okay, so that's the conversion factor there. Now the unit conversion, you must practice unit conversion in order to become proficient. And it's not just for chemistry. I'll give you an example. I went to Costco the other day, bought a bunch of kitchen towel without paying attention to what's on the kitchen towel until I got home and opened it up. Conversion factor. When you cook, the cups to teaspoons and tablespoons, you have to do conversion. Okay? So it's in everyday life. It's not just in chemistry. Right? It's a very important thing. And I think it's still available if you ever go to Costco there and pay attention. See, that's the thing about chemistry there. When you take chemistry classes there, you start to notice things in everyday life. And this is something that we actually talk about in class. There's an application. There's a reason for everything that we talk about in class. Okay, so let's try to do some exercise together. First example here. A bottle of aspirin tablet, 0.716 pounds. How many grams of aspirin is this? Well, if you are given a question like this, without the conversion factor, you say, well, I need the conversion factor to do the calculation. Okay? So the conversion factor will be, well, basically what we're asking you here, in plain English, we're asking you to convert pound into gram. We need the conversion factor. 1 pound is equivalent to 453.6 grams. Okay, so when you do this calculation, remember the approach that we introduced here. We always multiply the conversion factor. Okay, so we have 0.716 pounds. What is the conversion factor then? Where does the pound go? Where does the gram go?
Grams at top.
Grams on top, 453.6 grams, 1 pound. Now, if you set it up this way, pound and pound cancels out. That's what we do in dimensional analysis. Always multiply the conversion factor, but which conversion factor are you using? With this particular relationship here, you can write the conversion factor this way, or you can write the conversion factor this way. You just need to be able to determine which one you're going to use. We are converting pound into gram. So pound has to be, well, you're multiplying the conversion factor, so pound has to be able to cancel. You have to be able to cancel out the pound. Pound has to be in the denominator in this part, in this particular calculation. Okay, so if you plug in the number there, it's basically 0.716 multiplied by 453.6 divided by 1. We'll give you the answer. But how many sig figs?
3. 3.
Right here 3, right here 4.
3.
Well, first of all, when you do multiplication division, you go with the least number of sig figs. The least number of sig figs is 1, right? There's only 1 digit there.
Conversion factor.
Exact number, conversion factor. So you don't factor in, when you try to determine how many sig figs to keep, you don't factor in the number of digits in here. This is exact number. Here, in this quantity, you have 4 sig figs. Right. Okay. So the answer should have 3 sig figs. 324.777, the answer would be 325. You round it up, because this number is more than 5. You round this digit up by 1, 324. So that's one practice, one exercise there. The length of a virus, 0.00417 inch. What is the length in meter? You can see in this case, when you do conversion, when we ask you to do dimensional analysis, it may not be just one-step process. More than often, it's going to be a multi-step process. We are asking you to convert inch into meter. Okay, so we start with 0.00417 inch. We gotta have two conversion factors involved in this particular calculation. First, you convert inch into centimeter. Then you convert centimeter into meter, because that's what the question is asking you. Determine what is the length of a virus in meter. Okay? So in this case, 0.00417 inch, we want to convert it into centimeters. 1 inch, 2.54 centimeter. You always multiply the conversion factor. So in this case, if you do the first calculation, first step, inch will cancel out, leaving you with a centimeter. The question is not asking you how many centimeter in length is for the virus there. Now we need to multiply the conversion factor again. Now in this case, 1 meter equals to 100 centimeter. Okay, centimeter cancels out. And that will give you the answer. So you do 0.00417 times 2.54 divided by 100. All we're trying to focus on is what's going to be the unit in the end. If you do this calculation, the unit in the end is going to be a meter. That's what the question is asking you. Okay? So plug in the number, punch in the number on the calculator. That's the easy part. And the challenge here is that how to identify the correct conversion factor, how to plug in the conversion factor, you end up with the correct answer here. And if you do the calculation correctly, you end up with 1.05918 times 10 to the negative 4. How many sig figs are we supposed to keep? 6, 3, 4, 3. Why 3? This is the measured quantity. Leading zeros are non-significant. Remember those rules? When we were talking about the rules, I can see people started those off and fall asleep. It's kind of boring. Now you see the application of the rules. Hopefully that will help you to remember how many sig figs, how to determine the number of sig figs here. So this is the measured quantity. Okay, 3 sig fig in there. And the answer should have 3 sig fig. And this is the answer from your calculator. So the answer would be 1.06 times 10 to the negative 4 meter. Always include the unit. Okay? So these are the exact numbers. These are the conversion factors. They do not participate in determining the number of sig fig. So in this case, you get 1.6 times 10 to the negative 4 meter. So that's another conversion that we want you to be able to do. And I tell you, this course is all about definition and dimensional analysis. Just sometimes dimensional analysis can go a little bit more complicated than single step, 2 step. We may end up with multiple steps. In each step, you have to focus on the unit. Make sure you know which unit is being canceled out, which unit is left. In the end, you need to make sure that your answer has the correct unit in there. So another exercise here. Okay, the density of water at room temperature is about 1 gram per milliliter. What's the density in pounds per clock? Giving you all of these conversion factors. How do we set this up?